Here's a few examples of working with summations. A fairly easy one would be, suppose we've got a summation. They like to use I a lot. I like k better. K equals 1 to 4, say, of k minus 1, 3 to the k plus 1. And we just want to expand that out. And this is just basically understanding what the notation means. And remember, it just means take k to be all the numbers 1 through 4 and plug them into this formula and just put pluses in between. So when k equals 1, that's interesting. This guy dies, so we're going to get a 0 plus, which we don't really need to write, but it's good for the pattern, I guess. And then when k equals 2, we're going to get 1 times 3 to the, and then this is already up to 3. And then when k equals 3, we're going to get 2 times 3 to the 4. And then when k equals 4, we're going to get 3 times 3 to the 5. And there's 4 terms, which there is always going to be when you go 1 through 4, although 1 is 0. And so that could be confusing if you showed somebody this without the 0 and said this was a sum from 1 to 4. It's secretly that because there's one of them was 0. And so notice that if I write this out as a sum, a1 plus a2 plus a3 plus a4, the exponent is 1 bigger than which term it is, the sort of address, like in the sense of like a house address of the term. And the number in front is 1 less than this guy. That's because this was a k minus 1, and this exponent was a k plus 1. That's going to be very useful in the next problem where we try to package things up. So what if somebody gave you the sum written out longhand as, let's say, 3 over 5 plus 4 over 6 plus 5 over 7 plus 6 over 8 plus 7 over 9 plus ... plus let's say 100 over 102. And we'd like to express that as a summation. So the one thing we don't have to be, it doesn't have to be hard, is picking a letter. We get to pick the letter. I'll pick K. Well, I'll pick I, just to show you can use different letters. And we also get to pick where we start, and we're usually going to start with 1. You can start with anything you want. 0 is actually pretty cool. Mathematicians tend to do that. But 1's probably the simplest for the most part. Now, the number up top there, if we start with 1, the number up top is going to be how many terms are there here. And that, when you have the ... dots, that's not easy. You can't just read it off. It's not super hard usually. But we have to figure out, if the numbers are in this pattern, how many terms are there going to be. Now, we could try to do that first. And if you want to do that first, you can pause the video and do that. But I want to kind of show you how to do it second, because it's maybe a little more systematic if you do it second. Then we also need the formula. So we need some formula that's going to give us 3, 4, 5, 6, 7 on the top. Well, that's an arithmetic sequence. And it's a particularly simple one because it's going up by 1s. If I tried I, that would be 1, 2, 3, 4, etc. That's not going to work. But if I try I plus 2, that's a pattern that is going to match 3 through 100. As long as I have the right ending point, which I haven't figured out yet. So that's a very simple example of matching an arithmetic sequence written out to its formula. If you want to use the master formula of n minus 1 or I minus 1 times d plus 3, you can do that as well. D here is 1, the common difference is 1, and so you get I minus 1 plus 3 is I plus 2. But that's kind of overkill for that one. The bottom there, now that pattern is going to be just 2 more than that, and so it looks like I plus 4. Another arithmetic sequence. So here, one of the key things is you don't want to stare at these fractions and say, boy, that's a weird sequence of numbers, the whole thing. You want to look at each part of the expression and just match each part, and then just put them together as they're put together here. I can get the top, the numerator, I can get the bottom, the denominator, and then it's just going to be the ratio of those two things. Okay, so now I've got this pattern. To match, to figure out how many I've got, I can just match the 100 with the I plus 2. Because when I'm stopping, had better be the I that gives me I plus 2 equals 100. So that's going to be 98. And so there's 98 terms here. There would be 100 if it had started with 1 at the denominator, but I don't have a 1 or a 2 in the denominator, and so there's only 98. That would be the kind of less systematic way to figure that out. So you want to find patterns in parts of the expressions, put those patterns in as formulas, start at any convenient number you like, 1 or 0 are the most common, pick a letter, and then figure out how many terms are being added up. Okay, so that's probably, I think that's all we need for sort of basic summation problems. And I want to make it a short video, so there you go.